welcome to another one of my videos. So in the previous example, what we had was we got both LEDs to alternate. So in this particular case, if we run the simulation, notice if I press the push button or press the switch, the LED will stay on for as long as I want. This may not always be the case, or may not always be what you're looking forward to. You may want it to be edge triggered, and if you keep holding down the push button, you want the LED to go off, and then you let go for search. So let's have a look at the typical example in terms of what is happening clockwise. We'll look at the Y screen. So we have a signal coming in, which is the state of the switch or push button. It's always on high or pull up until we press it, then it becomes 0. So we've got a 5 volt signal on the output, 5 volts in, and at the point where we press it, it goes low to low voltage signal. So that's our switch. Then we have our LED. And at the moment when we press the switch, initially the LED is off. And as soon as we press it, it comes on. And it stays on until we let go, and it goes off. Or the other LED comes on. So what we want to do is create something like this, where let's call this LED 2, scenario 2. So as soon as the switch goes down, you want your LED to come down, maybe delay for 500 milliseconds, and then go back down and then stay down. So each of them being triggered by the state of the switch. So initially we've got the switch staying from 1, 1, 1, 1, 1, 1, 1, and at this point it becomes 0, 0, 0, 0 onwards. So one way of detecting this is between this point, or at this point when the switch is down, we have the current state, so we can initialize the state. We notice that the current state, which when the switch is pressed, is actually 0. And we expect the previous state at that point. So we've got a previous state. Previous state, if we go back 1, previous state is 1. So when the current state is 0 and the previous state is 1, which is the state of the switch, the state in the current state and the previous state being 1, we know that we've fallen edge of the switch. So the switch just moved from 1 to 0. And at that point, that is when we want to make the decision that the LED should go on. Same way, if we want to detect the rising, the previous state will be 0. The current state will be 1 for rising edge, then for falling edge. Yes, and depending on how long we introduce the delay, we can actually the right timing. So we go back to our code. Back to Tinkercad now, and we want to use a similar logic to trigger the edge of the LED. So what I have set up, I'm using processor directives. without going too much into it, basically what we have here is we find button, which in this case is the edge trigger. So as long as edge trigger is defined, we have different sections of the code that we want to implement. So in this first instance, either way, we have all the pins initialized and then also setup. When we go to the loop function, we double check if we want to use a trigger. So if we want to use a trigger, this code will run. If we are not using a trigger, then our previous code will simply alternate the LEDs will run. So let's look at using a trigger or edge detection. So what we have, as usual, we've got pin 13, pin 12 connected to the LED, then pin 7 connected to the switch. We have pin 7 connected to the switch. And we have defined a previous state and a current state. And we are simply setting the previous state to high by default. And in setup, we are using the pull-up switch. So connecting the switch to 5 volts by default. So by default, the switch state is 1. And then the LED as an output of the 2 LEDs going to. Now, when we can reset or when the loop initializes, what we want to do is connect the current state basically to the state of the switch. So we always read from the switch and pass it to the current state. So if the current state is low and then the previous state is high, it means it's moved from the falling edge, it's moved from high to low signal. The switch is pressed. And at that point, we just simply want to turn off the red LED. Then we want to turn on the red LED, and then we wait for 500 milliseconds before turning the LED off. Afterwards, we notice that we still have a current state being assigned to the previous state that we read. After we want to assign the current state to the previous, so we can always double check. So what we will notice is that current state, if the switch is pressed, current state is 0, and the previous state at this point was high. So on the first run, current state is slow, previous state is high, the condition is met, the LED will go on for 500 milliseconds and then switch off. But afterwards, after the if condition, we pass the state which was 0 to the previous state. So now the current state and the previous state are both 0. So of low. So if it repeats itself, this bit of the code will be skipped because in this case we are using the edge trigger. So if it repeats itself, current state is slow, previous state is slow, it will continue skipping until we'll now run this code until we release the switch and then press it again. So let's turn edge trigger on, run the simulation, and press. Let it comes on briefly. As soon as I keep pressing, I'm still pressing, but as soon as it doesn't come on again, I let go, press again, it blinks, and then continue pressing, nothing happens. Let go, press again, and it blinks. So now we've actually got to triggered by the by using combinatorial logic. So we've got if is the and is the double ampersand sign, which we have here, or implement or is right symbol, alternatively exclusive or will be. So we want to go back to line. Thank you for watching. See you in